Well, I think we can get started. Welcome back, everyone. We completed our introductory topics in chapter 5. And so now we're getting through the longer sections, 5.3, 5.4. Each one of these sections I'm anticipating might take a couple days to get through. And we only really scratched the surface of section 5.3. So now we're going to start in earnest. We'll probably make some good headway through the first initial examples. Before we jump back into that section, any questions at the moment? Okay, let's see how these go. So we're back to section 5.3. And we left off on this example number 1. Just a reminder of the context. We're looking at, looks like deafness in Dalmatians. And they are telling us that, still a tough word to say, congenital sensorineural deafness is a common form of deafness in dogs, often associated with pigmentation deficiencies. I don't know if having blue eyes is a deficiency, but maybe for dogs, a veterinarian can tell us a little bit better. That could be a sign of trouble. So we find here, a study found that 28% of Dalmatians are hearing impaired, 11% have blue eyes, and 5% are both hearing impaired and have blue eyes all at the same time. So that's kind of interesting data. If we trust that, we can construct a hypothetical 1000 table and start asking these interesting follow-up questions about the data. So first steps in actually constructing that table, like we mentioned, is we definitely need to know what the events are. Here, I just wrote them out. Some people might have done this. If you just write H and point it down at that, that's pretty good as well. If you call this B, point the arrow down, that works as well. Highlighter might help to say exactly what you're referring to. But it's always good to have somewhere on your paper, for your own benefit, some way to tell which event is which. If you've got that down, then it's going to help out with the next bit of work. So here's how it begins. If we want a hypothetical 1000 table, we start with 3 decently long horizontal segments. So these are going to be the rows of the table. Then we start grabbing the events. Start with H. Oh, question first. Oh yeah, we definitely do need to make something along those lines. What I was going to do with that is, once we have H, we're going to write probability of H is 0.28. And then probability of B is 0.11. And then, like you said, we ought to throw this down as well. Probability of H intersect B came out as 0.05. And we are using the intersection symbol here this time only because it said and right there. Does that make sense to folks at the moment? Awesome. So we have our 3 probabilities down. We're going to multiply each one by 1000 to get the right values. But now in the table with our 3 horizontal line segments, right where the red dot is here, I would put the event H. That's not required. You could put the event B and that would be okay. Below it, I'm going to put in the event H complement. So where the red dot is, H, that's saying your randomly selected Dalmatian is hearing impaired. Down below here, this is the good event. It means your randomly selected Dalmatian is not hearing impaired. It'll hear normally. Then, after we have the rows settled in and these values, let's put in 3 vertical line segments, constructing the rest of the table. So now we go to the event B, that the Dalmatian is blue-eyed. We'll put 1 right here. When we put it in as B complement, that means the Dalmatian has some other eye color than blue, so not blue-eyed here. Now, final things to put in. Because it's a hypothetical 1000 table, we need total counts. In fact, we need 2 total counts. We need a row total going this way. We need a column total going this way. And the 1000 in the hypothetical 1000 table goes all the way down here. So at this stage, it's going to turn into some weird little number game, but it has a certain logic to it. And essentially, every single problem is going to start off this way. The only things that would change is your event is not necessarily H or H complement. It's not necessarily B or B complement. If I change H to say T, then I just put T and T complement. So it's going to be a very, very similar setup each and every time we do this kind of work. Any questions or comments at the moment? Okay, so now we take all these probabilities and we multiply them by 1,000. And here's the logic. It's kind of that problem back in 5.1. Here where the red dot is, it says probability of H is 0.28. But H is the event that the Dalmatian is hearing impaired. So we can say there's a 28% chance of getting a hearing impaired Dalmatian if we randomly select one. But that's not what we're trying to think of. We're thinking of, suppose you randomly select 1,000 Dalmatians, multiply it by the probability of being hearing impaired. Multiplying this number by 1,000 just moves the decimal place 3 spots over to the right, and we get 280 of them. So if there's a 28% chance of a hearing impaired Dalmatian, then after selecting 1,000 of them, we expect 280 hearing impaired Dalmatians. Does that make sense to folks at the moment? Okay, so that 280 Dalmatians by the red dot, that is a total of some form. We go to this H row, there's 2 ways that the dog could be hearing impaired. With the red dot, that's a hearing impaired and a blue-eyed dog. If I move over 1 cell to the right, that would be for dogs that are hearing impaired, but not blue-eyed. If we move finally the furthest still to the right, that's the number of dogs that are hearing impaired in the total 1,000. So right here, we put in 280. All we're saying is we expect out of the 1,000 dogs in this table, 280 of them will be hearing impaired. So once I throw this in, we're just going to do it again with the probability of B. Multiply probability of B by 1,000. And we'll get 110 altogether. So we're expecting 110 blue-eyed Dalmatians. So now go to the B column. And just like before, if you're in this cell, these are particular types of Dalmatians as well, blue-eyed and hearing impaired. Still blue-eyed at this cell, but now they are not hearing impaired. These are the blue-eyed Dalmatians that hear just fine. Go to the column total here, and this is all 110 blue-eyed Dalmatians. So essentially what we're doing is trying to fill in every single cell of this table, and the cells, sometimes one, sometimes multiple taken together, is either going to be an intersection or it's going to be a union. So this is the last one we have to handle. Probability of H intersect B. I know I want to change the color a little bit differently on this one. This is the special one. The moment you see and, that's a big hint. It's what told us we have an intersection right here. It might be better to just put a redraw there. Now take 1,000 times probability of H intersect B, and we'll get 50, but we need to know where to put that 50. Here's the big hint on this. Right in this cell, let's kind of highlight it. That is H intersect B, right inside there, times 1,000. That's because we have both hearing impaired and blue-eyed all at the same time. So if you read that as a literal and, we'll take 1,000 times probability H and B. 1,000 times 0.05 will give us 50 altogether. And that 50 goes right exactly here. Let's make that pop a little bit more. So if you follow the color coding, it's really the massive thing that's going to allow us to solve the table. This was giving as an and statement. So we went down, wrote it as an intersection, multiplied it by 1,000, and right here, that's where the intersection lies. There's 50 dogs that will be hearing impaired and blue-eyed at the same exact time. Does that make sense to folks to that stage? Okay, so if they give us something that starts with H and B, we take 1,000 times those probabilities, we put them in the row total, the column total for wherever H and B is set. But the intersection symbol says take H going this way, take B going this way, and the intersection is the thing in the middle. So that's the major trick on getting through this particular table. If we're happy with that, well, we still have to finish the table, but now it's just a simple numerical game where we're going to add and subtract as needed to make all the totals that we put in still correct. So that's our next steps to take. Any questions or comments so far? Okay, so the way I'm going to fill out these tables, just for if you come back to these notes to use them for a reference, I'm always going to put in black the information I got after running through the work on the right. So I'm going to try to color code where every number goes. But if I put a value here in black, it means I'm just going off everything I could do from the probabilities here. Now we need to know the number that must go inside there exactly. Anyone spot it? It must be 60. We have to make the total to come out correct. So one thing you could do is, if you're like me and not as fast at numerically cranking these out, you could just go 110, or not that, let me try again, not at 1100. Take 110, that total there, subtract the 50, and that gives the value of 60 like you stated. So 60 goes in right there. Then we can just keep on doing it. Suppose if we wanted the value here at the red dot, take 280 minus 50, we'll get 230 right there. So we're well on our way. I can't put a value here just yet. I need a different computation. But we can get that value. Take 1,000 minus 110, and this will be 890. Now that we know that 890 goes there, we can go up a cell and find the value in this region. Just letting the calculator do its thing so it doesn't feel left out. Let's make it calculate for us. So I got the 890 by taking the 1,000 minus 110. Now for where this red dot is here, that particular cell, take the column total of 890, subtract the value of 230 right above, and now we have a value of 660 right here. So finally, we still need this total, but we're just taking 1,000 minus the 280 above, and that should give us 720. So if everything is going according to plan, we should have the entire hypothetical 1,000 table fully settled. It's not a bad idea to go and add these up. 50 plus 60 to get 110, 230 plus 660, check if it's 890, 280 plus 720, check if that really adds up to 1,000. And if you want really good evidence you did it right, add up going this way. 50 plus 230 should give us 280. 60 plus 660 should give us the 720 on the right. And 110 plus 890, yeah, that gives us the 1,000 to the right. So there's one unique answer to make all this come out, and that's finally the table we needed. Any questions or comments at the moment? Okay, the major thing that allowed the table to actually work was knowing that right inside here, let's put an arrow just for the sake of notes, this is where 1,000 times probability H intersect B actually went into. And it's only because they said intersect right there. Well, we did it, folks. Once we have the hypothetical 1,000 table, I want to show you what we did in section 5.2, which is really the whole punchline to this. If you're in section 5.2, then if you have a table, then really finding probabilities is really sort of just doing this. For example, we found the probability of root size is 5 by going to row 5, taking the number of outcomes, 1,760 of those nests, and dividing by 5,000. In the current problem, we'll divide by 1,000 instead. So this will be, I shouldn't highlight in yellow, yellow already has a meaning, but this will be the major thing we use to do every computation going forward once the table is set up. So let's take this. I'm going to copy it down on the next follow-up parts. You don't have to do that yourself. But as we go to solve part B and C, I just want to indicate where exactly on the table we're getting each one of those numbers to help out for when you have to do it as well. So I'll put one right here. Probably doesn't have to be that big, so let's shrink these down. And now here's the follow-up questions. Part B asks, what is the probability? So we can start off by putting down the answer to the question. We want a probability of something, probability that a randomly selected Dalmatian is hearing impaired or blue-eyed? So that's the probability question we want to answer. What's tricky about this problem is the or statement right there. The or statement becomes a union symbol, so we can write out this way. So I'll put in here probability of hearing impaired union blue-eyed, H union B altogether. So the or turns into a union symbol, but once you have a union symbol, here's what's going to happen. We're going to grab our probabilities by doing the following. Let me just try to find the right color here. Let's go with that blue. First, it says we want all Dalmatians that are hearing impaired. The hearing impaired Dalmatians are those two groups. 50 of them are blue-eyed, 230 of them are not blue-eyed. So we can start to write 50 plus 230 plus, and all I've taken care of is hearing impairment, the H outcome, grabbing those two numbers. Then we do this again. It says union B for being blue-eyed. We need to be careful here. The reason I didn't grab the total of 280 is because if I only grab the totals, that's a small mistake we can make in this. When we go down this way, since blue-eyed would be the 50 here, which are hearing impaired, the 60 here, which hear normally, we don't necessarily want to say 110 plus 280, because then we've counted the 50 twice. Instead, we'll go 50, 230, and 60. So that's going to be our full numerator. The whole thing's divided by the total of 1,000. And once we crank this out, we're in really good shape. Does that make sense to folks on getting through this one here? Okay, so let me bring back or rather than doing that, let's put in just one additional comment as well. If you're asking for probability of a union symbol, say H union B, then follow the color coding like we did right here. A union means you're taking multiple cells. So another way to think about that is, recall that the union is kind of an odd one. If we were to write this out in a normal way, we'd say H union B is the event that H occurs, or B occurs, or both H and B occur. So in other words, right here, that's H and B occurring at the same time. Down below, this is only B occurring. H did not occur this time. And right over here, this is the event that H occurs, but B did not occur. So a union symbol is really kind of weird. It means one happened, the other happened, or both happened. So that's why we grab those three values. And the actual computation, once we have the numbers, is really not too bad. 50 plus 230 takes us to 280, plus 60 takes us to, 340. Let me know if my numbers went sideways. But if you're dividing by 1,000, you just take the decimal place, which is right over here by the red dot, and move it 3 places now to the left. 0.340 is what we will get as a result on this one. What any questions, folks, on finishing off this problem here? Okay, the problem didn't ask for it, but let's put down interpretation on this as well. I'll put it in orange because it's not a required part of the problem. But once we got through this one, we can say there is a 34.0% chance that a randomly selected Dalmatian is blue-eyed, hearing impaired, or both. Blue-eyed and hearing impaired. Again, blue-eyed is not necessarily a good thing. They're kind of mentioning that might be a vision anomaly for Dalmatians. wouldn't know for sure on that. Well, any questions, folks, on getting through this one? Okay, what allowed this problem to go actually kind of fast, where the red dot is, the actual computation of it was the moment you have a hypothetical 1000 table, everything else just kind of falls into place as long as we know where to look. So I'm going to try to put these notes like you see here to show you where everything kind of goes. If it's H union B, that's going to be this event, and this one right here. But see above, if it's H intersect B, it's just that one count right here. Oh, and I should put 1000 in front of it, just to emphasize that's why we have numbers, not an actual probability. Well, let's try this again. We have a follow-up question down below here. It says for part C, what is the probability that a randomly selected Dalmatian has exactly one of these issues, hearing impaired, blue eyes? But they mean here not both if they say exactly one. So I'll say probability of exactly one issue. This is a particular one where I would just write down the probability statement using ordinary words like this here versus using fancy union symbols or intersection symbols. It really is a kind of OR, but it's not the same as this one. This is the inclusive OR because it allows both possibilities, the intersection right here. So when we go to solve this one, we want exactly one issue. Only dogs that are hearing impaired would be 230 right here. Because here, with it being blue complement, they do not have blue eyes. And if we want dogs that are, let's say, only blue-eyed, that would be the 60 right here. Where the red dot is, it corresponds to the column of B, so those are blue-eyed dogs. But it also corresponds to the row of H complement, so those are not hearing impaired. So if we want exactly one issue, we pick this count of 230, hearing impaired, this count of 60, having blue eyes. But this time we do not pick up the 50, that's having two issues, not exactly one. So this turns into 230 plus 60. And because it's a hypothetical 1000 table, we divide by 1000 on this one. Before we get the numerical value, does that make sense to folks on why we selected the 230 and the 60? Okay, a lot of these problems, they really just boil down to know what the table is saying, get the right values out, and just assemble them together. So again, it's just kind of some weird number game that we're doing. Now, when we're to this stage, the numerator turns into 290, divide by 1000, and then we get a probability of 0.29. So we've got it, folks. If we give an interpretation on this one, again, they didn't ask for it, so I'll just write this in the orange pen, which makes it look more like a comment. We can say here this time, compare it with the comment above. There is a 29% chance that a randomly selected Dalmatian is blue-eyed or hearing impaired. And if you stopped right here, that wouldn't be terrible in all honesty, because if you say someone is blue-eyed or hearing impaired, even if you're referring to a Dalmatian, if you say this Dalmatian is blue-eyed or hearing impaired, a lot of people hear that and think, well, it's one or the other, but not both. That's how the or is usually used in ordinary speech. But here, we ought to be really specific about this and actually say, but not both. Whereas on the top here, if you use an or statement using the union symbol, and they don't say specifically exactly one issue, it's an inclusive or. We're allowing for the possibility that the Dalmatian is blue-eyed, hearing impaired, and the 50 Dalmatians that have both conditions all at the same time. That shot up the chance to 34%. But down here, it drops down to 29%. So if you go to ask, say, a veterinarian, what's the chance a Dalmatian has blue eyes or hearing impairment? They might give you this figure, but you probably wanted to know about that figure above because it's including the doubles, having both issues at the same time. So this problem is really about unions and the follow part C as well. Any questions or comments, folks, on getting through this one here? Okay, and just for a mention of if you did this in an exam setting, as an exam, if you made a mistake on this table right here, it's not as bad as it seems. Let's suppose part A is 5 points. If I put 5 instead of 50, I might just lose 1, maybe 2 points. Then you'll still be using the table down here, but I'm going to redo my math. And if you use the table with your numbers in a correct way, you don't lose points again. So you don't get double dinged. So even if you made a simple mistake to start, keep on using your table in the follow-up questions exactly as is and use it correctly, and you still get all the rest of the credit. Well, that was our first one. Any questions at all, folks, before we try another? Okay, I would say before we go to another one, pay special attention to these kinds of buzzwords like the and versus the or. If you can find those, sometimes it makes a huge difference. And that's what's happening here on example number 2. So brand new problem means we need a brand new table. And here's the scenario. It says, suppose that you have torn a tendon and are facing surgery to repair it. So that's extremely terrible. Let's imagine it's like your ACL tendon or something like that. The surgeon explains the risks to you, it says next, as they should. They say the chance that the repair fails is 14%. So you could have your surgery attempted to repair, but come out realizing there was a total failure. Also, they're telling us that the chance of infection occurring is 3%. So 14% chance that they can't repair your tendon, maybe it's too damaged. 3% chance you get staph infection or something terrible from the hospital. And they tell us, moreover, the chance that at least one of these issues occurs is 16%. Now imagine a surgeon telling you that 14% chance that the surgery fails, 3% chance of infection, but you have a 16% chance of no repair to your tendon that's torn and you leave the hospital with a bad infection. So those are the risks. And think of parts B and C as follow-up questions you might want to know about before you actually go into surgery. So that's a setup. What we need to get going to even start is we need to know what the events are. They're talking about 2 things happening. Your surgery failed and you're getting an infection. So that's probably a good place to start. I'll think of this as the first event. Let's call this F. And I'll write it this way just to communicate that is an appropriate thing to do. On your paper, if you didn't write the event out at all, just in the table, that's okay as well. But anything you can do to indicate to yourself what event is what helps out a great deal. So F will be the repairs failing. Infection occurs at a 3% chance. That doesn't sound great, but sounds realistic probably. We can call that the event I for infection. Then they say the chance of at least one of these issues occurring is 16%. That last one is a really, really tricky statement, so we have to be careful with it. Let's compare it to part C. We're talking about exactly one condition. It was almost an or statement. If we're saying at least one issue, that's like what we did over here. Hearing impaired or blue eyes or both, that's at least one issue altogether. So the way this was written out, they're hiding an or statement somewhere inside this. This is really F, and I want to use the union symbol, I. Does that make sense to folks on that issue right here, highlighted in yellow? Okay, to me, this is really, really tricky wording. If I was to write this as a quiz problem or exam problem, I'd probably say, moreover, the chance of the F occurring or I occurring is 16%. Occasionally, they hide this kind of stuff and we have to find it. That's more of, say, a WebAssign kind of issue. Next thing we can do is, let's just write down these probabilities now that we have them. Probability of F is 0.14. We're going to have to multiply that by 1,000, so might as well do it right now. 1,000 times probability of F would be 140. So if the surgeon does 100 repairs as severe as this person who's consulting, he'll have 140 unhappy customers. Next, let's go to the infections. Probability of infection. This one's going to be 0.03. So 1,000 times the probability of infection, this would come out as a 30. Now, here's the tricky one. Anytime you have a union symbol, like what's happening here, there's an applied or statement. This one is not as easy as example 1, so we'll make a really big deal of the follow-up steps we have to make. But we can still start by saying probability of a failed surgery, union and infection is 0.16. So 1,000 times that, this will come out as 160. So we have our key numbers here on the right. Next thing we need to do is build the table. So let's start with the 3 horizontal rows, 3 vertical rows. 1, 2, 3. We've got a good start. 3 vertical rows, 1, 2, 3. We might as well just put total here, and 1,000 right here. Now, essentially every hypothetical 1,000 table, it always starts off just like this. Now we start throwing in the events. I'll just go in the order that the events actually occurred. So for F, I'll put it right here. So that's the failed repair. And F complement, this one here, that's the good outcome. That means your surgery, your repaired tendon was successful. Next, we go up to the columns here. I'll put I here for infection occurred. Here's I complement, meaning you came out of coming under the knife, clear of infection. So that's a great outcome. Now, once we get to this stage, we still have to place some numbers. I'll leave it up to the class. Any volunteers to say where 140 should go? Yeah, go ahead. Exactly. So it's going to be on the very far right. So this is a pretty decent way to visualize this. If you have 100 for probability of F, you're going across this way on the F row and just dropping the 140 right exactly here. If you've got that down, you're in really great shape on getting through these tables. Then we just do it again. I need to place the value of 30 coming from that information. So we go to I for infection, go all the way down to the now column total, and the 30 would be dropped right in that location. Now let's pause right here because this is where it gets tricky. When we were doing our first example, we had an intersection. They told us the probability that both happen at the same time. The intersection was just right there. So let's go down memory lane. When they gave us this intersection and we got a count of 50, that was great. 50 goes in one location and then we solved the table really, really quickly. But we also mentioned when you're dealing with a union symbol, that affects multiple cells all at once. So I have a count that has to be spread out across 3 different cells. To get through that, we need to be a little bit careful in writing this all out. So again, this red statement here is always going to be the trickiest bit about each one of these tables, and I'll try to keep that similar as we go through. Where a union fills in, just like we saw earlier, is going to be like this. It affects 3 different cells all at once. It's kind of rude like that. So the count of 160 goes in all 3 of those different spots. That's very, very tricky, but we can still make this work. Here's where the brand new 3-step process comes into play. We want to make a huge deal out of this one, and I'll say below here, use these steps for F union I. It's not so much about the F or the I, it's about the union. So I'll put it here in red just to emphasize it. Okay, so here's our step one in this process. What I want to first do is take this total and just add them together. So first we'll take the 140, add to that this column total of 30, and we get a value of 170 altogether. Now let's think a minute when we do this. When we took the 140, we are taking these two cells right here and adding them up to get the 140. But when we put in the 30, we were taking these two cells right here and adding them up. And that means right exactly here, we have double counted if we use the 30 and the 140. Does that make sense to folks at the moment with that double counting? Thought of it in a different way. Let's look at a table that's actually constructed. If we take this right here and this right here, that'd be taking the 280 plus the 110, and that gives us 290 altogether. Well, if we add up just these in this way, or sorry, say again. Oh, awesome. Thanks for spotting that. 390 altogether. That would have been a weird result. Now, if we take just the individual cells, we get 50 plus 230 plus 60, and that's going to be 340. But we can actually get the 50 out of this. When we took the 280, the 110, we double counted the 50. So take your 390, that includes double counting, subtract the 340, where we just grab the cells individually, and we get the double counted of 50. That's the major idea that's going to allow us to get through all this. Grabbing the totals, double counts the thing we really want in the middle. So let's say right down here, this 170 double counts probability F intersect I times 1,000. So if it double counted something, just like with what we did above right over here, we can bring back that missing cell that goes right in the middle. So first step we had to take was use the double counting. And now we're ready for our next step. This 160, it's spread out nicely and evenly the way it should. It never actually double counted. So we can take the 160, subtract 160 from the 170, and it brings back the thing in the middle, just like how we saw the 50 come back on the table above. Does that make sense at the moment? Okay, let's go to our next step down below here. I'll say for step 2, although we did it right here, it's kind of nice to just write it down step 2 because it's kind of part of the process of how we get to it. All right, 1,000 probability F union I, which came to a count of 160. This one does not double count. So if it didn't double count, we'll take the larger value of 170. Let's use a slightly different color here. We'll take the 170, the larger value, subtract from it the one that didn't double count, 160. We get a count of 10, and this is going to be 1,000 times probability F intersect I. And so that 10 goes in the normal place where an intersection would occur. It'll be right here. We finally got our 10 value, and that was the nastiest thing about this whole table. There's really two sets of steps. We wrote down our probabilities, we multiplied by 1,000, but then to resolve the union, which was spreading out counts amongst the cells, you need to use these steps right below here. This makes it a problem that's really kind of tricky. And so if you see anything that looks even remotely like an or in your problem, which conflates with a union symbol, that's the only time you're using these steps. If you have a problem that gives you an intersection, they're giving you the value right here by the red dot right away. Those are the friendlier problems. Well, any questions, folks, before we fill out the rest of the table? Okay, well, with how the rest of the table should go, let's first take this 10. I need to add to it a number that gets us to 140. So 130 will do the job. Now, right over here, subtract 10 from the 30 below, we get a count of 20. So that ought to work for us. Here, take 30 away from the 1,000, so we have 970. Now, on this cell, we're taking 130 away from 970. That should give us 840 altogether. Lastly, we can do two things. Either take 140 minus 1,000, that will give us 860, or just take the 20 plus the 840, that'll give us 860 as well. So it looks like we finally have the table. And the way to double check that really is working out is you could just calculate probability of F union I again. If you did that, you'd have to take the counts of 10 plus 130 plus 20. That will give you the 160 that we are expecting. So if those numbers do add up, where it's highlighted in purple here, then we've done it, folks. We finally have our hypothetical 1,000 table. Well, any questions or comments so far, folks, to this stage? Okay, with that table in play, getting through the rest of the problems is not so bad. It's all about this right here. Once we have the data, this question will be quick, and so will this one, once we shrink that down a bit. So here's our follow-up questions to go along with this information here. Part B now asks, what is the probability that your surgery results in failure with an infection? So we're asking for the worst case event that you could ever have if you're going to repair a tendon. Well, this word right here, to me, is really tricky. It's just not the word I would rather it would have been. So the word with, it's either going to be an or it's either going to be an and. Anyone see which of the two options it truly is? I agree. If it says you have a failed surgery with infection, the whole thing could be reworded as the surgery failed and you have an infection. That's the same sentence altogether. You know, this is to me the hardest thing about probability. I would love if they just put and right there. But if you go to solve probability problems and you're working with the public, maybe you're consulting with people or working with a different department, they're not necessarily going to use the words that we use. They're going to tell you their problem in their own language, and we have to infer, are they talking about an or and right here? So that's the major challenge of probability, is the communication of it, writing out the questions or giving the interpretations. So right here, when they said with an infection, this is a glorified and statement, which means we'll use an intersection symbol. So the probability statement can now be written as, once I get that pen working, was the probability surgery fails, that's going to be the event F, and at the same time, we have an infection, that's the event I. So this question is kind of silly in a way, because we're almost essentially looking at it. If you looked at the prior steps up above, we did involve the intersection already. We just need to know what is the one count that goes in that numerator. Has anyone spotted it? It would be the 10, good call. When it says intersection, we're really just referring to one cell where F and I cross or intersect. That's kind of the way, the reason why we'd like to call it intersection. So the 10 goes here, the 1,000 goes down below. Now it's just 10 divided by 1,000 to give 0.001. Let me double check that. I think I have too many zeros here. Let me try again. Should be 0.01. Let me move those decimals. Yeah, I think we're in better shape there. So there is a 1% chance with this data, if they're accurate, that you will be in the worst case. No repair to your tendon and you have a gnarly infection all at the same time. Well, any questions, folks, on getting through this one? Okay, again, part of the thing that's tricky about this is knowing where to grab your data once you have the table. But if you look through these notes again, when you're solving problems, either on a quiz or a homework problem, I'll try to always highlight where we're getting the information. So let's try this out again. Part C says, what is the probability that the surgery was successful? Now, that's kind of tricky. If they say the surgery was successful, that is not the event F at all. F meant the surgery failed. So they're talking about F complement on this one. Then it goes on, and I like that they literally said and right here. If they said and in that statement, we'll put an intersection in the middle between our two events. Then it says you are dealing with an infection. Let's double check. I means you're dealing with an infection. So that's the ordinary event I on this one. So we want to know the probability that, hey, your tendon is repaired, but you are sick. Your wound is not happy at the moment. That's not the worst case ever. So we want to know what's the chances of that occurring. The denominator is settled. It's the 1,000 from the hypothetical 1,000 table. And now we need to fill in the numbers in the numerator. We want F complement intersect I. Anyone see what the count should be for that value? It would be the 20, absolutely. Think F complement going this way, I going this way, and where the highlighting overlaps, right here, that's the intersection. So we get a count of 20 on this one. And the whole thing becomes now 0.02. So there's now a 2% chance that you have a successful surgery and, well, you also have an infection. Sorry about that. But that's not, again, a bad situation. Well, we got through it, folks. That's the hypothetical 1,000 table so far. And these notes are pretty long. We're on page 4 of 7. That means we'll be doing a lot more of these just for the sake of practice. And my goal is to have this finished probably on Wednesday's class. But if it takes us to Thursday, that'll be just fine. If you have questions, if you want extra examples, please don't hesitate to let me know. I'm happy to bring more examples in each one of these sections. Well, have a great night, folks. And just a reminder, since I've been forgetting to remind folks, I have a class that starts 10 minutes after we end on Monday, Wednesday, and Thursday. But Tuesdays are special. If you have questions, I am available longer after class. I don't have a follow-up one. So if you have questions tonight, I'll be very happy to help out and it won't feel as rushed. Well, have a great night, folks, and I'll see you all on Wednesday.